Step 1. Go to the official website and download Godot. For Windows and Mac, click the big button. For Linux, just use your package manager. Step 2. Optional. Check the minimum requirements of Godot's editor. Step 3. Optional. If you don't know much about programming, finish the free online computer science course of Harvard University. It's recommended in the docs and you can learn a lot of useful things there. Step 4. Optional. Read the About section. In summary, the most insightful things are: native C# is not mature yet. GDScript is recommended for normal use and C++ extensions when optimizations are needed. There are some public demonstrations to quickly check the capabilities of the engine. Link in the description. You can work with any text editor you like. Godot works with files directly and it detects external modifications without problems. There is a list of supported functionalities, but I wouldn't bother about it yet. Godot works mostly in plain text. Git works great here, just initialize correctly the ignore files to avoid junk. Godot has a terminal client that could be useful in task automation. Godot versions follow a major-minor patch structure. The current version is 4.2. Godot 3 and 4 have enough differences and breaking changes, so if you have a specific need you want to be fulfilled, make sure to check if your version can do it. An example of this is web game support. It's working best in version 3. By default, stick with 4 as that version will catch up eventually. There is a changelog for the documentation. You can read it and refresh it from time to time with the new content. Godot is extensible with plugins that enable third-party capabilities. Features that require third-party proprietary licenses like console devkit libraries are not in the engine by default but can be added as plugins. Step 4. Optional but recommended. Read the introduction of Getting Started. In summary, in Godot, the game is a tree internally. The tree is composed of elements called nodes, which are the minimal pieces we will be working with. An audio player or a 2D sprite are examples of nodes. When the tree grows, there are too many nodes to be aware of, so we group them into single units called scenes. The player character or level are examples of scenes, but take into account that scenes are just group nodes, so they can be nested. Both nodes and scenes can communicate between them directly, but this could end up in spaghetti code pretty quickly. To avoid it, we have signals, an event-based communication system that uses messages called signals. For example, if the player loses health, it can emit a signal of having lost health, and then the heads-up display can update itself when the trigger of that signal fires. This observer pattern is used in multiple parts of the engine, so check it out too. It is important to note that the node tree is not visible from the editor. Scenes are just shown as single elements to simplify the development process. Step 5. Read and do the Getting Started tutorials. They help you familiarize yourself with the editor and are a good opportunity to play around. Don't follow the instructions word by word in your first try. Read a couple of paragraphs and try to do them without looking at the instructions. You will either learn what you read or introduce a bug that will be an excellent opportunity to learn how to debug and read the documentation. If a problem happens, you have the following sources to look for help: the tutorial, the Ask forums, link in the description, the in-editor documentation is on the upper right side of the editor in the Inspector tab, and Google. Have special care with string literals, both in the editor and in the code itself, because the engine relies on them to resolve method and class names. For example, I had a problem where my root node script was called GameGD, but the one assigned to it was called PlayerGD. So when I tried to connect with signals these nodes, the game complained about it, and the editor tried to connect the player with its own script, which didn't have that much sense, all because of a wrong place string, so be careful with that. Step 6. Choose between the 2D and 3D tutorial depending on which type of game are you interested in. 3D is more complex and it's a bad idea for newcomers, but the underlying ideas are mostly the same in both cases. Step 7. Create an additional feature for the 2D 3D tutorial you did. I just added dynamic colors to the score depending on how many points you have. This step has the only purpose of you exploring the documentation in a real scenario without any guidance. If you struggle too much with this, it could be an indication that you need more theory, practice, or both. If so, do the optional steps you may have skipped. From here on, there are just recommendations and what to do next. You could jump right into your first serious project, but the following steps are good investments. Step 8. Optional. Read the best practices section in the manual. Step 9. Optional. Create an entire game with minimal features and any weird mechanic you came up with. For example, I have decided to create a game about lighting lanterns by blowing the flame from one to another, and when you blow the flame it shoots fire in the direction of the air is moving. It will be a physics game, so lanterns will move after being blown too. It's just a single mechanic with a couple of features to explore, but this project already has animations, background, UI, shaders and physics. It also works great as a sandbox for testing features before introducing them directly into bigger projects. If you want more ideas for games, you can check this video or ask in the comments, and I see you here in the blink of an eye.